Okay, guys, let's just start the class. If anybody else is attending, that would be better, but that is fine. Um, Welcome to DBS 211. As I mentioned, for the other session, we have a full 30 students. I asked some of them if they can join this class. So we have maybe 15 students, but we will review the outline first, and we continue with some basic database definition today. So let's start with some of the uh, documents that we have uploaded to Blackboard. The first thing is 14 weeks breakdown that I uploaded as addendum. My name is Farhad Purhadi, and I'm your instructor for this semester. Here is my email address if you need to contact me. So on the Blackboard, if there is anything basically that I need to communicate, I will add it to announcements. Then we have getting it started. Here we have some material that was given to me by Continue Education. I posted them here for you to review. My information, and then we have the course outline. This is the most important one that we have to review because that has the learning outcome, and I would like everyone to be on the same page on what we are learning for this semester. So please, read through the rest of the subjects on this outline, but that's what we are looking for, learning outcomes for this semester. The first one is describe database concepts and database management system. These are some basic database definition that we will review, some today and some next week. Apply a relational model with constraints to develop a database. So let's say someone gives you this Excel file or a flat file, a text file, and they are asking you to transfer data to a database. What is your first step to do that? So we usually go through a data model, create the structure of a database, and then we get to the point that we need to implement on the database. For this semester, we are going to use SQL Server. So you will get basically in the middle of the semester after the first test, you will get a virtual server, virtual machine with SQL Server on it installed, and then you can basically practice structured query language, the language that we communicate with the database. But if we are going back to this point, relational model, so we create a schema structure of a database, and then we implement with constraints on the database. Constraints are a set of rules to prevent user from making mistake. For example, here within Excel file, we have a unique identifier which is a customer ID. So on Excel file or any flat file, if you type it wrong, then what happens? Nothing there to prevent you. You made a mistake and you lose the consistency of your data, integrity of your data. But on the database side, the constraints prevent that. Of course, you or database designer is responsible to identify them and create them, but after that, database management system will take care of the rest. Compose a database using data definition language to solve a simple business problem. So data model is really a graphical solution to a real world data structure problem. When we create a data model, a conceptual model, then again, when we get to the point of implementation on a database, we need to create physical and logical objects. For example, I need to create the tables. the tables that we have here. So from this Excel file, let's say we get to a conceptual model. This is Microsoft Access. This is not conceptual model, but it looks like this. If I want to open, actually, maybe I should open one. Most of the times I'm using Lucidchart for ER diagram, entity relationship diagram. Let me just open one of them. So it looks like this. When we are creating a data model, we are creating entity relationship diagram. It looks like this. When we have our
sorry, can you please share your screen? We can't see nothing.
Then we get to any database management system, does not matter. I'm teaching almost the same course in the morning, and we are using Oracle there. But it does not matter if it's SQL Server or Oracle or MySQL, all of them. When you are creating any of your physical objects or logical objects, then you use data definition language. Data definition language, or DDL, we use in order to create our objects. So it's a set of statements, SQL statements, structured query language statements that we communicate with the database what we want to be done. Here we have create table statement, alter table statement, create view, create index. These type of statements all categorized as part of data definition language, or we call it DDL statements. Then the next one is manipulate data using data manipulation language. So that's another category within structured query language. Data manipulation language, or DML, that when you have your database structure, you have your tables and everything else created, then you would like to insert, update, and delete your data within that database. So we go through these two set statements, data definition language and data manipulation language, and then the select statement. That's the main part. We do all of these just because we want to retrieve information from our database within the shortest amount of time that is possible. So we learn all SQL statements after our first test. Examine a database to optimize interactions and privileges and privacy. These are mostly going back to grant and revoke statements, granting permission and revoking statements. And this one goes back to indexes when we optimize our database. So basically from A to Z, for this semester, at the end of this semester, if you get a flat file or Excel file that you have, all the data, then what do you do? What are your steps? Are you going through, conceptual model design? You're going through normalization, and then you have your structure, and then you implement it on any database management system. By the end of this semester, you should be able to do all of these from A to Z, designing, implementing, and being able to retrieve your information from your database. So that's the learning outcome for this semester. Please, at any time you have any question, just speak up and ask me your question.
Hello.
Okay, here we have some detail of what we talked about. We have some definitions. As I said, some for this week, and some of them we go through next week. Then we compare today what is a file-based system, what is a database system, and so on. These are all definition and design. Then database modeling, data models that we are using, either being a top-down design or a bottom-up design. going through normalization, first NF, second NF, and third NF. And these are all done in order to create the structure, create something like what I showed you as a entity relationship diagram right on here. So after that, we get to a structured query language. And as I said, that's a language that we talk to database management system in order to get something done. And we go through all types of data manipulation language, data definition language that is been specified here as well. And then the constraints. These are, the type of constraint. We have 6 of them actually. Default is not listed here, not null, check, unique, primary key, and foreign key. So we go through these types of constraints to see in what cases we should create them based on a specific business rules. And then we get to the rest of the implementation. We get to metadata, data dictionary, and so on. So these are the detail of what we are going to do for this semester. And then when we get to the evaluation, we have 2 tests for this semester, 20% each. The first test is 20%, and it's based on design, definition, and the major portion for this semester, which is a normalization. How do we do normalize and create this structure? You will have 1 project, and within that project, you can work in groups of 3 per group. That is going through step by step, creating the structure of a database, and then implementing on SQL Server. And then basically there are some select statement that I ask you to do. And the final exam is 30% as well. Any questions up to here? Go ahead, Chan. Sorry, I didn't hear that.
Can you hear us, sir? Right now.
I can't hear you now. Sorry about that.
Okay, so
basically
you didn't open your screen sharing. We can't see anything from your screen. We just listen to your voice.
My mistake then. Sorry about that. I apologize and thank you for mentioning that. Okay, so let me get back to sharing. Okay, so now you can see my screen.
Okay, thank you.
Sorry about that. So I'm stepping back then. So let me go through what we said just to see all the links that we have. So we said on Blackboard, when you get to the course, you have the announcements. We have getting started. These are all the documents that I uploaded. I got them from Continuing Education and uploaded here for you. Then we have my information. Here is the email if you want to contact me. I do my best to get back to you within 24 hours. Here is the basically outline. I reviewed this learning outcome. So I talked about this learning outcome from DDL, DML, and basically design definition. And I went through some of these concepts here that we have for the detail. So I talked about basically design that we go through today and next week. I talked about relational model and base modeling, including entity relationship diagram, information level, logical. And then I talked about basically normalization, first normal form, second normal form, and third normal form. And then after this, we get to SQL, structured query language, that we have here basically for data definition language, data manipulation language, and the constraints that we have within the database. And then we have data dictionary and grant and revoke permissions and so on. And at the end, I talk about the modes of evaluation, 40% for the 2 tests that we have, and 1 project, which is 30%. Again, you need to basically enroll within groups. I will talk about that more in detail. And then we have the final exam, which is 30%. Any question up to here? You guys can hear me, right? Okay, I just want to make sure that I don't have the problem again. Okay. So Mohammad Reza, is that okay if you or I lower the hand that I know at least for the next time? Okay, perfect. Thank you. All right, so here we have the addendum, and in order to get to that, if you go back to here, you have it within getting it started here, addendum, and also you can get to it from course documents here. So what do we have there? I do my best to follow weekly schedule, what we have there, and basically, it's possible that I have to, based on the progress of the class, I have to change the topics for that class. But we have, again, some definition. Then we get to type of keys, type of tables, and then this is a top-down approach. By next week, we will do some entity relationship diagram design. Then the week after, we get to normalization. And for the normalization, we spent a couple of weeks with 2 projects. Within each project, we will have 5-6 user view in order to design. And what a user view is any form, report, or anything that you would like to store data from. So that this Excel file, for example, is a user view. I can give this one to you and ask you to design based on this Excel file. And based on this Excel file, at the end, if you design it properly, then you will have a structure like this. So that's a normalization part. And then the project, I will upload the project here on 3rd week. We will have our first test either on week 5 or 6. I prefer to be on week 6, but again, it goes based on the progress of the class. Then we start on SQL. I would like to spend more time on SQL rather than on design and definition. So that's why I said either 5th or 6th week we have the test. Then we get to SQL statements for the rest of the semester, including DDL and DML and grant and revoke permissions, how to back up, how to restore, and this type of things. And then we have final exam on December 9. Any question? Okay, so textbook. Here, this one is open, basically 2nd edition of the textbook. You can download that from here. If you want printed copy of that, you can buy hard copy of that. But otherwise, if you would like to download just a PDF, you can download it from here. When I specified here, first 4 chapter or first 5 chapter, this one, 4 chapter is like 20 pages. It's not that much, so don't panic when you hear or you see, chapter 1 to 4, to be read for the next week or so. Okay, so get back to course document. Here is that addendum we talked about. And here is the week 1. Every week I will upload PowerPoints or what we are going to review to that folder. I uploaded 2 PowerPoint where we review 1-1, but we will leave 1-2 for next week. This one more we are talking about data models and so on, and I would like to give you the chance to read through the textbook and so on before we start on kind of conceptual design, tables, and so on. So we will leave this one for next week. And then the project will be uploaded here. Last semester, I was able to, have a link for recordings added here. This semester, they prevented that. So you have to go to basically to the source, which is, I think is here. So you should go here and watch the recording. And usually takes some time to be available. So right after class, it may not be available. This semester, I had a lot of emails going back and forth between faculties that students cannot see the link, but at the end it was by design, so they don't want anybody to have the link. Everybody has to go from the menu item in order to see that. For the tools, for the groups, you go to the tools and you go to the groups here. So you will have the chance of basically registering within a group. I created 10 groups, so max of 3 per group. There are, as I said, there are only 8 registration for this class. So please don't register each one of you within one group. I would like to be a minimum of 2, maximum of 3 within each group. Any questions? Okay. Yes, it's a self-enrollment within those groups, so you can basically enroll within any of the groups that you would like. Okay. All right, so let's get to basically some of the basic concepts that we have for this week. And then we will get to more detail starting from next week. As I said, there are only 8 registrations, so the expectation they approve this class, usually minimum is 12 students, but they approve this class in the hope that there will be more registration. So I don't want to go for both PowerPoints, and then next week I have to repeat that. Okay, so let's start with data and information. Every one of us, we have data to store. Doesn't matter either to be, companies' data that we have or personal data to store. These type of data that we see, for example, within this Excel file, we call it raw facts because they are very detailed and they haven't been processed to reveal their information. We usually store very detailed data and then we create reports, or we use aggregate functions to create summarized reports. And that's where managers can make a good decision based on. Otherwise, based on data that you see here, nobody can make sense out of it. Otherwise, it needs to be processed to create the information. We are talking about database management system. We have database engine within each database management system. We store logically related data in an organized manner within each database. So when you have your conceptual design, conceptual model, then you start using data definition language, SQL, structured query language, in order to create the tables. And what we see here within this, where is that? Right here. Here, we see all these tables. Either we go, basically, we have the option here to see I created one already. So that's what we have. We created basically these tables. And we see that they are stored in an organized manner. All the orders are in one table, customers on another table, product another table, and so on. So that's what the plan is, to store all of our data in an organized manner, the way that they are related to each other. We are talking about data again. We said end user data, either personal or from the company, from your workplace. We need to store them, and that's what we have. That's the whole purpose here. When we are going to each one of these tables, we see data that is being stored. Like, for example, the basic select statement. We are saying select start, that means all the columns from what table, for example, from customer table. And then I just use function F5 in order to execute, and I see my data within that customer table. Another set of data that we have is called metadata, data about data or data dictionary. What is that? It relates to the structure of tables that you have. You create the schema, and then you start creating your objects, your tables, your views, your indexes, and so on. When you have all these objects, then how does database management system know that what tables you created, what are the permissions on it, what are the columns within each table, what is the data type for it, what is the size, which one is the primary key, and so on. That is the data dictionary that we are talking about. Within each database management system, we have basically different tables that are used. For example, here on SQL Server, you are using information schema. Information schema, for example, I want to see my tables. You see all these tables that you see here, they are basically part of data dictionary. So I can just highlight I want to run and use F5 in order to see. So these are my tables. That's what we mean by data dictionary, metadata, but database management system will take care of it. You don't do anything. You can use basically as a read only, but you're not allowed to do anything else. You have access as a user, depends on your permissions on the instance of SQL Server. As a user, you are able to see a few of them, not all of them, but if you are database administrator, that you have system administration permission on the instance, then you can see all data dictionary tables. So actually, you know what, just give me a second, maybe you can see even SQL Developer. We are not using SQL Developer, which is for Oracle, but at least I want you to see that every database management system, they have their own type of data dictionary and different type of, let me get to, let's say, here, just want to create a connection. So here within schema, we have some tables as well as you can see. And the same thing, we can do a select statement, but this one is user. These are the tables that I have here, but here is user tables, for example. The name is different. Here I use Control Enter in order to execute, and these are the tables that I have. Then I have user tab columns and so on. So the name is different, but the concept is the same. Any database management system that you are using, DB2 is the same as Oracle, most of data dictionary tables. The DB2 is an IBM product. MySQL is basically Oracle product as well. Access belongs to Microsoft. SQL Server belongs to Microsoft. So we have a lot of different database management systems like Postgre and so on. But for this semester, we are basically using SQL Server for that purpose. Again, database management system. What is a database management system? Is a set of programs that are compiled together in order to provide you with a product called database management system. So each module within this product may take care of some functionality of database management system. You may want to back up your store. So one module, one exe does the job for you. Then we get to database design. Database design or database designer. Database designer is the person who's creating the schema objects, like what we saw here with conceptual model that we saw. If I get back to it here. What we see here, and database designer is the person who's maintaining this structure. Usually big companies, they don't allow a developer to get to this point of designing. In medium size and small size companies, even medium sized companies, sometimes developer does the job of designing a table. And that's why we would like you to understand the concept, even if you are not basically designing or maintaining the tables. Still understanding why it's been designed is a big plus for you. And if you understand the schema of your database, then you can write a better statement, a better SQL statement. Some of you may be registered within this course just because of structured query language. You want to learn how to work with the database, retrieve data, and so on. And you may not be even allowed to insert, update, and delete. But learning the concept, what is a primary key, what is a foreign key, and these type of things helps you to write a better SQL statements. Because sometimes I see, programmers, developers going to database administrator. Database admin is the person who's making sure that the database is safe, is secure, the access to it, and everything running smoothly on database. So programmer developer goes and say, you know what, I ran SQL statement and it takes 2 minutes. It's very slow. We may need to upgrade our server and add more RAM, add more memory, and this type of things. But I tell you, 99% of the times when database administrator, a DBA, goes through SQL statement, 99% of the time is to select the statement that needs to be changed. And believe it or not, sometimes from that 2 minutes, you get to less than a second without changing the server, just changing SQL statement. So that's why it's very important to understand the schema, understand the structure, how it's been laid out, how they are connected to each other, and so on. Okay, so we are talking about file-based system versus database system. We had around 1960s that we had databases on mainframe systems. Then mid 60 we had databases on desktops. Okay, I just want to make sure that there is nothing happened again with my PC. So please, can you give me a feedback if you guys are okay? You're hearing me, I hear you. Okay. Okay, very good guys, thank you. Just want to make sure that I don't have the same problem as before. Okay, so going back to file-based system versus database system. Prior to 60, before databases, even after 60, because at the beginning it was on mainframe, most of the companies, software companies, they were creating their applications, their programs using file-based systems. Like they were connecting to files, flat files. So doesn't matter if it's a DAT file, if it's a text file, it still is a flat file. So we had so much problem with that approach because you see that we have 3 programs here and each program is connecting to one of the files. One of the problem was that as soon as the first person was connecting to the file was locked. So we didn't have concurrent users on basically a specific file. The first person had to close the program and release the file, then the second person could connect to it. And the reason for locking the file or being in use was that one person could overwrite all the changes that the first person had made. So they didn't want that to happen. So either they made it a way that nobody else can connect to it after the first person was connected. So if we are going through this Excel file again, there are tons of different issues, but some of the most important ones, when I'm looking at this file, I see lots of duplication of data. Why do I need to store customer information 10 times, 12 times? Everything is the same up to here. So when I go to the left, I see that we are repeating all the customer information just because products that customer has bought many different products, and that's the only reason. So we have a lot of redundancy of data here. That is one of the biggest problems that we have on a file-based system, and that is causing different issues. Don't think that redundancy exists or duplication exists only within the same file. No, if we are looking at what we have here, I have student information here, and I have student information within advising file. That is still redundancy. You have it twice. So many years ago, it was about 11 years ago, I moved to this house. What happened is that I went to the branch and I changed my address. After that point, I did not receive my statement from my credit card. Excuse me for a second. So I contacted the credit card company and they said, you haven't changed your address. I do understand their point. It's for my own security that they were doing it. I believe they have fixes in place today, but at that time I had to basically call the branch to change my address, and also I had to call basically credit card department in order to change my address there. It doesn't matter if it's within database. As long as we have, duplication, is still having it within database doesn't make much of, sense to the point that we want. So redundancy, regardless of being on a database or on a file-based system, creates a problem for us. And that's what we see here. We have student information once within this file and once within class files, still duplication exists. What else we see here within this file? Updating data. Let's say a customer calls and say, I changed my address, or I changed my phone number, or contact person has been changed. So what do? We need to update this file. And usually we should update it only once, but in this case, for the case that we have for the file-based system especially, we had to update it many times. And let's say I updated on 11 records and I forgot to change the next record. What happens now? I lost the consistency of my data. I lost the integrity of my data. So duplication creates inconsistency. Goal of a database management system is to minimize redundancy, maximize consistency. Again, concurrent users we talked about. So let me go through this one, see if there are any other disadvantages that I forgot to talk about. So we talked about data redundancy. We talked about inconsistency. We talked about maintaining data. And basically, we forgot to talk about when we are joining. If, for example, my manager comes to me and say, you know what, I want all the students, I want the class information and advising information in one report. I'm not saying it was not possible. It was possible, but it was taking more time. So these are some of the disadvantages that we had with basically file-based system. Then we had database approach, database systems. We had different data models. We started with hierarchical model, then we moved to network model, then we moved to relational. That's what we are studying today. And we will talk about all these different data models, disadvantages of each next week. But what we have here, we have a database system and we have database management system. So we have database, this one is database engine, database management system. You always communicate with the database engine through database management system. You cannot go straight, to the database engine. In fact, SQL, structured query language, is translated by database management system. So database management system receives SQL statement, translates it to a language that database understands. We'll send it to database. Database does what it's asked to do, like if we are retrieving data, sends data back to database management system, and that's where we get them. It depends with what you are doing, or you're working on an application. When you install the application installs necessary files from database management system that they are using. Usually applications, they are hiding what type of database management system they are using. And most of databases, they allow quiet installation. So you can put your logo and install Express edition of SQL Server, let's say. So when you install the program, you have no idea even what database management system is used. Here, I have the dashboard for SQL Server, let's say. Here is the DBMS itself. I execute from database management system. That's the first basically 1.12 figure that we see here, I'm executing the SQL statement right from database management system. But sometimes you have the program with nice interface with forms, reports, and so on. The program will communicate with database management system. You do not issue any structured query language like what we see here. So what are the advantages? Obviously, it's a lot easier to join the tables together, as we see within this SQL Server. Now, the only thing we need to do is that if, for example, my manager comes to me and say, give me all the customers with their orders. Customers are within this table. Orders are within this table. Then the only thing within a minute, I can join these two tables together and retrieve data. If my manager wants to see all the products within each order, then I have to join customer to the order, then order to order line, and then order line to the product in order to get the description of the product that each customer has bought. So it makes it very easy, while, as I said, if you wanted to do the same thing from different files, it may take hours to do that. It's not within seconds, in minutes. The ability to share data between applications. So now that we are sharing data, I'm jumping ahead and going back again. So now that we share data with different applications, you see all these three programs that we had, and each one of them was connected to a file. Now all three of them goes through database management system, and database management system connects to a centralized database. Now that we can share data between different applications, obviously we do not have redundancy. I do not need to store student data within class file and advising file. I store student information in one table only. Sorry, this one doesn't work. Okay, it worked. Concurrent users. So obviously you have to buy client access license. Microsoft calls it CAL. You have to buy the license, the number of licenses that you buy, client access license, in order to connect to SQL Server in this case. But when you buy and you have enough licenses, then we have concurrent users connected to the same database, and database management system will take care of all the problems that we had with a file-based system. Like, for example, what happens if two people retrieve the same product? One of them changes the price from $4 to $6, and the second person changes from $4 to $8. Database management system will stop the second person because the data has been changed. So all the locking, all the issues that we had with the file-based system now is taken care of by database management system. Improved security and recovery of data. We have two levels of security. We have authentication. So you get authenticated to the instance of SQL Server. But when you get authenticated, you are not allowed to do anything yet. Then you need to be authorized to access a specific database, specific tables. Let's say you can limit, to the column, what columns they are allowed to see and they are not allowed to see. Recovery of data. Now we can recover up to 100%. It all depends on DBA, database administrator. One of their biggest job is to create a disaster recovery plan. it all depends on disaster. Even though Microsoft SQL Server or any other database management system today allows you to recover up to 100%, but it depends all on the recovery plan that you have. We had some clients, they thought that paying a DBA is not necessary. So what they did at the beginning, they hired the DBA. DBA created a maintenance plan within SQL Server, which is not a big job. And then what happened, just give me 1 second. So they created maintenance plan for them to back it up and so on. The backup was on the same machine, and then they had another program that was uploading the back file, the backup file to a cloud server. At the beginning it was working, but what happens, once in a while it needs to be restored to see if it's okay, what has happened. The DBA set it up a way that if there is any problem, it sends an email in case of failure. But what happened, the bridge to the email server was broken. It couldn't send any email. So they lost about 3 months of work just because of that disaster recovery plan that they had in place. Yes, we can recover, but all depends on what we are doing and what is our plan for that. Data integrity can be maintained through constraints. We talked about this one, data integrity of a database. You need to identify the constraints. So if you create a table, let's say here, I create a table. Let me go to one of these databases. Let's say I create a customer table, but I do not create a unique identifier. If that happens, then the database allows you to insert duplicate customer ID. So you need to identify them, you need to create them, and from that point on, as I said, it will be taken care of by database management system. Database management system development tools. We have different libraries. We have COM objects that when you install, basically it will be installed on the machine. And you can use them, just a function call or a library call in order to use that functionality. And you do not need, for example, backing up a database. I mentioned that if you have an application, you can do a quiet installation of SQL Server, either the standard edition or express edition. What happens then? The next step is if I go to the file backup, then I need to make a backup of that SQL Server database. But as a programmer, as a developer, I don't know what needs to be done. I don't know database management system inside out, how to do the backup. So what happens, Microsoft provided some functions. Okay, make a call to this function, pass the database name, pass the path, and it will do the job for you. So it will make a big difference using the tools provided and getting our job done. Item number 7 is a big item for those of us that know how data dependency was working with old programs. Like if we had to use RPG within AS400 or COBOL, maybe you heard the name or not, we had to specify data size basically for each file that we had. So old programs, third generation language programs, they were storing the size of the field within the program. when we are talking about size of the field, for example, if I go here and I go to design, you see the size, this one is 45, this one is 40 character, 30 character, and so on. So previously, this size was stored within the program. Now imagine if my manager to me and say, you know what, state now I want it to be 10 character, to be 5 character. Previously, what we had to do, changing it here and changing it on the program, then just because you change the size of a field, you had to recompile your program and send it to your client. But today, there is no need. You change the data structure, all the programs will work without any problem. We had even previously some programs that were getting only the size within the form, and then when we were changing it, it was not crashing. The data size was changed. The application was not crashing, but it was truncating data. But not application software that we have today, they embed the field size within the application anymore, which is a big plus for us. Data dictionary, we talked about data dictionary. Multiple views of data. So we have different category of employees within each company, and each category may need a subset of data. For example, here, for me, I just need, for example, a student name and the class. That's maybe good enough, a class listing. But coordinator, they may need more information of the student. So now we have multiple views or subset of data. We can easily use projection and selection within a selected statement and create report based on a specific columns that we need. And even if we get to a point that we want to do that frequently, then we can create a view which is a logical object, and we can get the data from the view. We can have different privileges, different permissions for each user. We have the company that I am working for. We have application for automotive aftermarket parts. So we even allow the user to access the database and retrieve data from database. If they want to use other softwares like BI, analyze their data, they can do that. So we create read-only access for them. We do not let them to write to the database. So these are, huge benefit to the companies that you can restrict user from accessing maybe a specific tables, they cannot run a stored procedure. The only thing that they can do is reading from specific tables. Any question, guys? Okay, so as I said, I'm not gonna go more than this for this week. I will let you read through some of the chapters. The PowerPoint is uploaded. This data model PowerPoint, week 1, 2. These are the differences. There are some definitions, but we will need them in order to progress for next week. And very soon, by end of next week, we get to a point that we start working with tables, different table types, different type of keys within the database, and so on. We will get hopefully end of next week, we will practice a few entity relationship diagram, and I will give you some practices to do at home, and the week after we will review the solution to those practices. But for this week, I want to see if we get more registration and give you the chance to read through the materials that we have. Any questions? Okay, just let me stop the sharing for a second. I see some private chat there. We are starting from zero, basically. I'm just thinking what else we can have there. Read through the book that we have, the textbook, and if you need, any other material, let me know, and I will dig to see what else that we can provide to you. But let's read through the. I think there are 3-4 chapters that I suggested you to read. The textbook is, as I said, the textbook is right here. You can download it. You don't need to buy that. Yeah, it's just here. You go to textbook and you should be able to download it from here. You can download it from here. No problem. Okay, guys, I will stay online for anybody has any questions. I'm gonna stop sharing right now. I'm gonna stop recording for any questions that may be private. The recordings. Sorry, everyone. Looks like we have some issues. It kicked me out. Okay. So as I said, I will be available for your question. Otherwise, thank you very much for joining and stay safe. And I will talk to you guys next week.